Hi everyone. Today we're going to talk about patterns in Earth's climate and focus on the cycles and sudden changes that naturally have happened on Earth in the past. So let's get started. So, what are the patterns we see in Earth's climate? Earth's climate has many natural patterns, and this includes slow changing cycles and even sudden shifts that are very abrupt. Studying our past climate helps us understand future risks and even our human impacts on the natural cycles of the climate on Earth. So let's talk about some long-term natural climate cycles. So the natural climate cycles of glacial and interglacial periods that we've observed in the past on Earth are driven by something called the Milankovitch cycles. So what we've noticed is that in the past, um, the Earth's climate or temperature has shifted from interglacial, which are warmer periods, and glacial periods, which are cooler periods, and it's been a cycle. And scientists believe that these cycles are due to the changes in the shape of the Earth's orbit from more circular to what we call more elliptical or oval shaped. We also have changes in the Earth's obliquity or the tilt of the Earth. This angle can also shift, which can cause different variations in how the sunlight reaches the Earth, and even the orbital precession, which is the direction of the tilt of the Earth, can change over time. And because of this, ice ages have occurred on Earth approximately around every 100,000 years. And these are natural shifts that have happened before human impacts that we see today. Um, Outside of long term slower shifts, Earth has also seen natural abrupt climate shifts as well. These are rapidly changing shifts that can happen within decades. An example would be the Dansgaard Earthshear or the Heinrich events, where we see very sharp or abrupt uh, temperature increasing events or temperature decreasing events. And these events are thought to be linked to changes in our ocean currents or the melting of ice sheets. So scientists normally study ice cores, which are what you see here, drilled ice from very deep inside the earth or under the earth's surface. And doing so, these ice cores helps us understand the climate history of earth because they have trapped gas inside them. And it can also give us information on the temperature, the amount of carbon dioxide, and even dust that have existed in the atmosphere of Earth over the last 800,000 plus years. And it also reveals cycles, these long term and short term cycles within the Earth's atmosphere that have happened naturally in the past. The thing is, just because um, we have these slow shifts in the Earth's temperature when the interglacial, the warmer periods, and glacial, the cooler periods, doesn't mean that within those areas, or sorry, within those time periods, there was extreme stability, nothing changed. Even during the warm periods, which we are now, we are in an interglacial period. There are climate variations. For instance, things like changes in rainfall, changes in the ocean currents. And so on may lead to regional droughts and shifting monsoons that are more short term. So just because this seems stable long term doesn't mean it's completely even or completely the same. Things shift, shift even at short term um, time period. So natural instability remains within the stability, long term stability that we see. So, what are the causes of these natural oscillations of our up and down flows? So, some scientists believe that the changes in the sunspots from the sun, sometimes the sun gets these spots. This can change the amount of solar energy that Earth's receive, and this is also a cyclic thing that happens. Um, Volcanic eruptions can cool down the climate. The ash can reduce the amount of sunlight reaching the Earth's surface, and also changes in ocean and atmosphere patterns, such as the El Nino and La Nina patterns, may also cause these natural oscillations. El Nino and La Nina is the changing in ocean patterns, as you can see, where the warm ocean currents shift. direction, and so do the winds. And this can cause major disruptions or changes in the climates of different regions on Earth. So why do recognizing these patterns matter? Well, climate has its limits, and as we've seen in the past, it can naturally shift slowly or quickly. And studying these patterns helps us predict future risks. It also helps us set a baseline for how the natural climate of the Earth operates to compare to our human-driven change to understand our Earth better. So in the next video, we're going to talk about the role of life on Earth's stability. And life plays a key role in carbon, water, and energy cycles on Earth, and it's a major connection between all the other spheres that drive the Earth system. And we're going to also explore how ecosystems influence Earth's stability. That's it. Thank you.